Hi students, I am Raghavan, chemistry faculty from ALPHORES college. I invite you all for the ALPHORES chemistry e-learning classes, session 41. Okay, in the last session, we have completed the properties of alkali metals, that is 1A group elements. Chemical properties like reaction with water we completed, reaction with hydrogen, and oxides we completed, halides we completed, carbonates we completed, bicarbonates completed, okay, and their solubilities which are important for the objective examination point of view, all the points we completed. Now today we are going to discuss about compounds of sodium, that is sodium hydroxide, okay, compounds of sodium hydroxide, NaOH. Compounds of sodium, that is sodium hydroxide, it is commonly known as caustic soda. Caustic soda. Okay, so we have to see today, we have to complete. So that is preparation and properties of sodium hydroxide. Okay, that is sodium hydroxide is commonly known as caustic soda because of its caustic properties. So it is called caustic soda. Okay. So what is that caustic property? It can decompose the skin proteins. So that is called caustic property. Okay. So therefore it is called caustic soda. Now in this, see, caustic soda is prepared by one causticizing process, that is one method, and second method is electrolysis method. Okay, first method is causticizing process and second method is electrolysis method. In this electrolysis method, the sodium hydroxide, that is caustic soda, can be manufactured by two methods are there. Electrolysis methods are two. One is Kastner-Kellner electrolysis method. Kastner-Kellner's, okay, Kastner and Kellner's electrolysis method, and second method is called Nelson's electrolysis method. Both are electrolysis only. Both are electrolysis methods. So Nelson's electrolysis method. Okay. So caustic soda, sodium hydroxide, can be prepared by two methods. Causticizing process, the second method is electrolysis method. Okay, the electrolysis method is again two types. One is Nelson's electrolysis and the other one is, that is Kastner-Kellner electrolysis method. Kastner-Kellner electrolysis method. Okay, right. The first one is Kastner's electrolysis method. Causticizing process, it is causticizing process. This process is also called Gaussage method. This causticizing process is also called Gaussage method. It is also called Gaussage method. Okay, remember this, the alternate terms are important for us. It is a causticizing process. That process is also called Gaussage method. Okay, and what is the process for this? Very simple reaction for this. 10% sodium carbonate solution is made to react with slaked lime, that is calcium hydroxide. Excess of calcium hydroxide, it is in the excess quantity. Okay, 10% sodium hydroxide solution reacts with excess of slaked lime, that is calcium hydroxide, forms NaOH, that is caustic soda is formed, plus CaCO3, calcium carbonate. That's all. Very simple process, that is Gaussage method or causticizing method. Okay, what is the statement of this process? 10% sodium carbonate solution is made to react with excess amount of calcium hydroxide, forms caustic soda, that is sodium hydroxide. This method is called causticizing process or gaussage method. Okay, remember the two terms, causticizing or gaussage method, right? That is one method. Next one is, let us take up Kastner-Kellner electrolysis method. Kastner-Kellner electrolysis method. Okay. Second method, preparation of sodium hydroxide, preparation of caustic soda by Kastner-Kellner, by Kastner and Kellner, Kastner-Kellner electrolysis method. Kastner-Kellner electrolysis method, which is used for the preparation of sodium hydroxide, right? Now, in this method, caustic soda is prepared from, it is extracted from brine solution. Okay, now, so in Kastner-Kellner electrolysis process, I will explain the central idea of this. Brine solution is electrolyzed. Brine solution is electrolyzed in presence of mercury cathode and graphite anodes. So therefore, the process is also called mercury cathode process. It is also called mercury cathode process. Mercury cathode process. Okay, remember that name. Kastner-Kellner process is also nothing but mercury cathode process. Okay, mercury cathode process. In this process, mercury is acting as a intermediate electrode, that is both cathode as well as anode. Okay, now brine solution is electrolyzed in presence of mercury cathode, and graphite anode. Mercury cathode and graphite anode, that is in outer compartments. Okay, because a cell is divided into three portions. The cell is divided into three compartments. Okay, like this, three compartments. In outer compartments we have graphite anodes. And the bottom, the mercury is placed at the bottom of the cell. It is acting as, the mercury is placed at the bottom of the cell. It acts as cathode. In outer compartments, mercury layer is acting as cathode. Okay, mercury cathode and graphite anodes. Outer compartments, graphite anode and mercury cathode. Okay, so in outer compartments, brine solution is electrolyzed in presence of mercury cathode and graphite anode. Okay, so it forms sodium reduced and combines with mercury cathode and forms sodium amalgam. Okay, in outer compartments, what reactions are taking place? Brine solution is completely electrolyzed in presence of mercury cathode and graphite anode. In outer compartments, brine solution is electrolyzed in presence of mercury cathode and graphite anode. Okay, so as a result of electrolysis process in the outer compartments, the sodium ions reduced at mercury cathode and forms sodium amalgam. Sodium amalgam is formed in the outer compartments. You can say Na2HG or NaHG. Okay, amalgam, sodium amalgam is formed in the outer compartments. Now, during the process, chlorine gas is liberated in the outer compartments. It escapes through the side tubes. Chlorine gas liberated in the outer compartment escapes through the side tubes. Okay. Then there is one eccentric wheel placed at the bottom of the cell. Eccentric wheel. Due to the rocking motion of the eccentric wheel, the sodium amalgam now completely shifted into the middle compartment. Sodium amalgam is completely shifted into the middle compartment. In middle compartment, now the sodium amalgam undergoes hydrolysis. Sodium amalgam undergoes hydrolysis in presence of in presence of, it undergoes hydrolysis in presence of mercury anode and iron cathode. Mercury anode and iron cathode. It is iron cathode and mercury anode. Okay, so it undergoes hydrolysis. So in middle compartment undergoes hydrolysis. Outer compartments we have electrolysis reactions. Okay, so in middle compartment sodium amalgam undergoes hydrolysis, forms sodium hydroxide in the solution. Okay, so once again the complete let us write the equations, electrode reactions. Okay, then only you can understand clearly. So outer compartments we have and middle compartment. First let us take up outer compartments. Outer compartments. Outer compartment. In outer compartments, which reaction is going on? It is electrolysis process. Okay, outer compartments, electrolysis process. Okay, in outer compartments the electrolysis process is going on. That is, brine solution is electrolyzed. Brine solution is electrolyzed in presence of mercury cathode and graphite anode. That is, mercury cathode and graphite anode. Okay, graphite anode. So it ionizes this first Na plus and Cl minus ions. Now Cl minus, it loses its charge undergoing oxidation. So now Cl plus Cl liberates as chlorine gas. The chlorine gas liberated. So this is the brine solution completely in the cell. So during electrolysis the chlorine gas is bubbled at graphite anode. The chlorine gas is bubbled at graphite anode. The liberated chlorine gas escapes through the side tube collected into the chlorine cylinders. Okay, the chlorine gas is liberated. Now this is at anode. This is the anode reaction. Now at cathode. Okay, so at cathode is the mercury cathode. Now sodium ions get reduced at mercury cathode, forms sodium amalgam, NaHG, forms sodium amalgam. That sodium amalgam is formed at cathode. Okay, this is the reaction takes place in the outer compartments. That is, in outer compartments which reaction is taking place? That is electrolysis process. Okay, outer compartments sodium amalgam is formed. Chlorine gas is liberated at anode. Now in middle compartment, next one is middle compartment. Middle compartment. In middle compartment hydrolysis reaction takes place. In middle compartment hydrolysis reaction takes place. Middle compartment hydrolysis. Outer compartments we have electrolysis. Middle compartment we have hydrolysis. Right. In middle compartment sodium amalgam Na2HG undergoes hydrolysis. It undergoes hydrolysis in presence of mercury anode and iron cathode. Mercury anode, Hg as anode and iron as cathode. Remember, in this method, in this process, mercury is acting as intermediate electrode due to induction. Okay, so in this process it forms sodium hydroxide NaOH plus Hg. Okay, that is sodium hydroxide is formed in the reaction. Hydrogen gas is liberated. Okay, hydrogen gas is liberated at cathode. Okay, hydrogen gas is liberated at cathode. So here also you can say directly 2 electrons. So we can say that hydrogen gas is liberated at cathode. Okay, sodium amalgam is hydrolyzed. Sodium amalgam is hydrolyzed in the middle compartment. Sodium amalgam is hydrolyzed in middle compartment in presence of mercury anode and iron cathode. Mercury anode and iron cathodes. So it forms sodium hydroxide in the solution. Okay, and hydrogen gas is liberated and escapes through the side tube. Escapes through the side tube. Escapes through the side tube. That is Kastner-Kellner electrolysis method for the preparation of sodium hydroxide, that is caustic soda. Okay, so outer compartment we have electrolysis of brine solution. During the electrolysis, chlorine gas is liberated at anode and mercury is reduced at cathode and forms sodium amalgam. In the middle compartment, hydrolysis reaction is going on. So sodium amalgam is hydrolyzed in presence of mercury anode and iron cathodes, forms sodium hydroxide in the solution, that is almost 40% dilute sodium hydroxide is formed, and hydrogen gas is liberated, escapes through the side tube. Escapes through the side tube. Okay, that is Kastner-Kellner process. Okay, the next process is Nelson's electrolysis method. Okay, so this is Kastner-Kellner process, or it is also called mercury cathode process. Okay, in this process mercury is acting as intermediate electrode. That is the point, it is important for objective exam. Okay, next method is Nelson's electrolysis method. Nelson's electrolysis. Nelson's electrolysis method, or it is also called perforated diaphragm method. It is also called perforated diaphragm method. Nelson's electrolysis method, or it is also called perforated diaphragm method. Nelson's electrolysis method. Next method is Nelson's electrolysis. Nelson's electrolysis method. Nelson's electrolysis method, or it is also called perforated diaphragm method. Okay, so in this method, let us explain the brief diagram of this. It is a perforated U-shaped steel vessel. It's a perforated U-shaped steel vessel. Perforation means having holes. Perforated U-shaped steel vessel. Perforated U-shaped steel vessel. Okay, so itself it acts as cathode. Itself acts as cathode. Okay, and a graphite rod is suspended into the electrolyte. A graphite rod is suspended into the electrolyte. Okay, as anode, graphite anode. Okay, so the electrolyte solution we have to take electrolyte, that is brine solution is used as electrolyte. Okay, brine solution is taken as electrolyte. So here let us put one outlet and here one inlet. This is inlet for steam. Inlet for steam, H2O, that is gas, steam, and it is outlet for hydrogen gas, H2 gas, and the inner side we have a asbestos lining. This is asbestos lining process. This is asbestos lining, right? Asbestos lining. Now, here we have a receiver which collects sodium hydroxide, which collects NaOH, Okay, right. Nelson's electrolysis method. So here also brine solution is used as electrolyte. Now the process. Brine solution is electrolyzed. In presence of steel cathode and graphite anode. In presence of steel cathode and graphite anode. Steel cathode and graphite anode. I repeat again. Brine, so that is U-shaped perforated steel vessel is acting as cathode. Itself acts as cathode, okay? And the inner side of the cell is lined with asbestos. This is asbestos lining. Okay? This is U-shaped steel vessel acts as cathode. Okay? This is graphite anode. Okay? This is steel vessel as cathode. Right. Perforated U-shaped steel vessel is used as Nelson's electrolytic cell. Itself acts as cathode. The inner side of the cell is lined with asbestos. Okay. Brine solution is taken as electrolyte. A graphite rod is suspended into the electrolyte, acts as anode. Okay. 3 points are important in this. Brine solution as electrolyte. Second, perforated U-shaped steel vessel as cathode, and graphite rod is arranged as anode. These are the 3 important points, right? Now, that is brine solution is electrolyzed in presence of steel cathode and graphite anode. So it ionizes first Na plus Cl minus. Okay. At anode what happens? The primary change Cl minus gives rise to Cl plus electron, that is oxidation. So Cl plus Cl gives rise. The chlorine gas is liberated at anode. Okay, so the graphite anode, the chlorine gas is bubbled and liberated. So the liberated chlorine gas, it is collected into the chlorine cylinders. Right, that is done. Next, at cathode what happens? At cathode, before going to take up that cathode, so a blast of steam is allowed. Blast of steam means water vapor. The blast of steam is allowed from the bottom of the Nelson cell. Okay, from the bottom of the Nelson cell, steam is H2O gas. It contains both H plus and OH minus ions. The OH minus ions of steam combines with sodium ions and forms caustic soda, NaOH. I repeat again the process. So after the liberation of chlorine gas, after the liberation of Cl2 chlorine gas, okay, then sodium ions penetrates through the asbestos lining. It is penetrating through the asbestos lining and deposited at perforated cathode. Got it? Once again, sodium ions penetrates through the asbestos lining and deposited at perforated cathode. Okay. When steam is allowed from the bottom of the cell, the OH minus ions of steam combines with sodium ions, forms sodium hydroxide. The sodium hydroxide formed in the reaction, it is collected in the receiver placed at the bottom of the Nelson cell. Okay, sodium hydroxide is collected in the receiver. Okay, now at cathode what happens? At cathode, that is H plus ions. At cathode, H plus ions get reduced. H plus ions get reduced and liberated as hydrogen. H plus H gives rise H2 gas. Hydrogen gas is liberated at cathode. Hydrogen gas is liberated at cathode. This is Nelson's electrolysis method. Nelson's electrolysis method is used for the preparation of caustic soda. Okay, the main process will explain short. Okay, that is, brine solution is electrolyzed in presence of steel cathode and graphite anode. During electrolysis, chlorine gas is liberated at anode, escapes through the side tube collected into the cylinders. Sodium ions penetrate through the asbestos lining and deposited at perforated steel cathode. Fine. A blast of steam is allowed from the bottom of the Nelson cell. The OH minus ions of steam, the hydroxide ions of steam, combines with sodium ions at cathode, forms sodium hydroxide. The sodium hydroxide is collected in the receiver placed at the bottom of the Nelson cell. Hydrogen gas is liberated at cathode. That's all. This is about Nelson's electrolysis method. Nelson's electrolysis method. Now, let us see some important chemical reactions of sodium hydroxide. Some important chemical reactions of sodium hydroxide. The important chemical reactions such as reaction with metals, reaction with non-metals, okay, reaction with zinc, okay, some important chemical reactions of NaOH. So this is manufacture of sodium hydroxide is completed. Okay, sodium hydroxide, how we prepared the sodium hydroxide? Sodium hydroxide is prepared by two methods. One is causticizing process, okay, and second method is electrolysis method. So electrolytically sodium hydroxide can be prepared by two methods. One is Kastner-Kellner electrolysis method or mercury cathode process, and second one is Nelson's electrolysis method. Okay, that is causticizing method is also called Gaussian process. Okay, that we have done. Okay, next heading is chemical properties of sodium hydroxide. That is chemical properties of sodium hydroxide. Chemical properties of NaOH. Okay, first chemical property we can say reaction with non-metals. Reaction with non-metals like phosphorus. Reaction with phosphorus. Sodium hydroxide solution NaOH. NaOH plus water. Aqueous solution, that is reaction with non-metals. When white phosphorus is added to sodium hydroxide solution, it forms, that is, it liberates phosphine gas and sodium NaH2PO2, sodium dihydrogen phosphate. Okay, so it is balanced like this. So it is 3. Okay, make it 3. Yes, 8. Balanced. Okay, that is when white phosphorus reacts with sodium hydroxide solution, aqueous solution of sodium hydroxide, it liberates phosphine and forms sodium dihydrogen phosphate. Okay, 1 second. So now it is 3 plus 3. Yes, it is 2 3s are 6. 6 plus 3 9. Yes, now it is balanced. Oxygen atoms 3 plus 3 6. Yes, 3 2s are 6, balanced, perfectly balanced. So that is when sodium hydroxide is reacting with white phosphorus, liberates phosphine gas and also forms sodium dihydrogen phosphate. Next, reaction with halogens. It is very important reaction. Okay, so chlorine when reacts with cold and dilute sodium hydroxide solution. It is cold and dilute sodium hydroxide solution. It forms sodium chloride NaCl plus NaClO, sodium hypochlorite, sodium hypochlorite, sodium hypochlorite and water. Okay, balance the reaction, it is 2 NaOH. Yes, it is a disproportionation reaction, we know that, because oxidation state of chlorine atom decreases in one product and increases in another product. So what is mean by disproportionation reaction? That is a redox reaction in which a single element undergoes both oxidation and reduction is called disproportionation. The reaction of chlorine with sodium hydroxide is a disproportionation reaction. Okay, this is cold and dilute condition. Next one, chlorine when reacts with hot and concentrated sodium hydroxide NaOH. Hot and concentrated, it is cold and dilute. Next one is hot and concentrated sodium hydroxide solution. It forms sodium chloride NaCl and NaClO3 plus H2O. That is sodium chlorate. Sodium chlorate. It is also a disproportionation reaction. You can observe the change in oxidation state. So chlorine atom is 0 and in this product is -1, in this product it is +5. Okay, because for the objective examination point of view, we have to remember the change in oxidation state of the chlorine atoms only. Okay, because it is only the important points for the objective examination point. So this is reaction with halogens. So it is reaction with non-metal, it is also reaction with non-metals is completed. Okay, next one more reaction let us observe. Reaction with zinc metal. Reaction with zinc metal. Reaction with zinc metal. Okay, now zinc when reacts with sodium hydroxide solution, it forms sodium zincate Na2ZNO2 and liberates hydrogen gas. Sodium zincate is formed. Let us take it is this 2 NaOH. When zinc metal is added to sodium hydroxide solution, it liberates hydrogen. Okay, so what is the product formed in the reaction? It is sodium zincate. Okay, sodium zincate. These are some properties of sodium hydroxide. Okay.